Good morning, sir.
Good morning.
Good morning, sir.
Good morning. In last class, we discussed about LTI system, that is linear time invariant system, and this was the lecture that we discussed in the previous class. We did a derivation of for an LTI system through which we can find the output of the LTI system for any arbitrary input, and the formula that we have derived is known as convolution sum. So this is the formula, that is yn is equal to k from minus infinity to plus infinity. X of k into hn minus k. So this is the formula with the help of which you can find the output of the LTI system for any kind of arbitrary input, provided the impulse response is given to you. Right? That is, this impulse response is known to you. If this impulse response is known to you, then you can find the output of the given LTI system, that is discrete time LTI system, for k from minus infinity to plus infinity, right? And xk is the input signal. So this formula is also denoted with the help of this particular symbol, that is y of n is equal to xn. This is the sign of convolution. Xn in convolution with hn, where xn is the input and h of n is the impulse response. Impulse response is the output produced by the LTI system when the applied input is the impulse signal, right? So if you are applying an impulse signal, the output that you get from the DT LTI system is known as the impulse response of that particular system. So in a numerical problem, generally hn and x of n is given to you, and from xn and h of n you have to find the output signal, that is y of n. And this is the detailed mathematical expression for the convolution, that is, which is also known as convolution sum, that is k from minus infinity to plus infinity, x of k into hn minus k. So in any numerical problem, this x of n and h of n will be given to you, and from these two signals, that is from the input signal and from the impulse response of the system, you have to find the output signal, that is y of n. So today we are going to discuss the numerical problem, and we will discuss the step-by-step procedure to solve the convolution sum. So this is the steps which are involved to find the convolution sum. There are 5 steps which are there, and with the help of these 5 steps, you can find the output of any DT LTI system, where DT stand for discrete time and LTI stand for linear time invariant system, right? So you can find the output of any DT LTI system with the help of these 5 steps which come under the convolution sum formula or convolution sum procedure. So first step is that x of n and h of k will be given to you in the numerical problem. So step number 1 is plot x of k and h of k. You have to sketch the graph of the x of n and h of n, right? We have replaced n with k. यहाँ पे हमने n को k से replace कर दिया है. वो करना भी जरूरी है, क्योंकि जो summation लेते हैं हम वो k पे लेते हैं, right? So in numerical problem, x of n and h of n will be given to you. Replace n with k, where k is also an integer when number, right? So you have to plot the given signals, that is x of k and h of k. This is the step number 1. After plotting x of k and h of k, you have to, the step number 2 say that you have to fold the hk about vertical axis to obtain h minus k. We have to flip the signal, that is from h of k we have to obtain h minus k, right, which is known as time inversion operation. So this is the step number 2. Step number 3 says that time shift h minus k by n naught units. You have to time shift the h minus k by n naught units. Now this n naught unit can be positive or negative, right? So time shift h minus k by n naught units to obtain hn minus k, right? So we have to obtain by time shifting h minus k signal that you have obtained in the step number 2 by n naught unit. Now n naught can be positive or negative, right? So for positive values of n naught, that is when n naught is greater than 0, h minus k will be shifted towards the right hand side, that is it will be delayed by n naught samples, right? It will be delayed by n naught samples. For n naught which is lesser than 0, that is if the n naught is negative, for the negative values of n naught, h minus k will be shifted towards the left hand side, that is advanced version. So this is the step number 3, right? जो स्टेप नंबर 2 में आपने h minus k obtain किया था, उसको n naught यूनिट से या तो आपको डिले करना है या एडवांस करना है, डिपेंडिंग ऑन द साइन ऑफ n naught. If n naught is greater than 0, then h minus k will be shifted towards the right hand side, that is a delayed version. And when n naught is lesser than 0, then h n naught minus k will be shifted towards the left hand side, right? That is by n naught samples. Step number 4 is multiply xk and hn naught minus k to obtain the product of x of k with hn naught minus k, right? Multiply both the signal xk and hn naught minus k. Step number 5 is add all the sample values of the product sequence, that is xk and hn naught minus k, to obtain the values of the output at n equal to n naught, right? So these will be very clear to you when we try to solve the numerical problem. So you can go through these 5 steps, kindly read these 5 steps for 2 or 3 minutes, then we will start the numerical problem. And if you have any question regarding these 5 steps, then you can ask. And if the question is needed to be answered at this stage, I will answer it. Otherwise, when we do the numerical problem, it will be all the steps will be very clear to you. Yes, any question?
No, sir.
So this is the numerical problem that we are going to do today. And most probably later on we will discuss more numerical problem in the tutorial class. So x of n is given to you in the numerical problem. It is a finite data sequence. It has 3 samples in it, and we have arrow marked at this particular position showing that this is the value of the signal at n is equal to 0. This is for n is equal to 1. This is for n is equal to 2, right? There are only 3 elements, that is only positive values are there for x of n. Similarly, h of n is given to you, that is 3, 2, 1, and again the arrow is marked at the starting element of the data sequence, showing that this is the location of the origin, and the values towards the right hand side will be positive, and on the left hand side, although there is no value on the left hand side, all the values towards the left hand side will be counted negative values, right? But all the samples on the left hand side are 0, so that's why it is not given. So h of n is again a finite data sequence, 3 elements, 3, 2, 1, n is equal to 0, the value is 3. For n is equal to 1, the value of the magnitude of the sample is 2. For n is equal to 2, the sample value is equal to 1. So x of n and h of n is given to you. You have to find the output signal y of n with the help of convolution sum. That is, y of n is equal to xn in convolution with hn. Now, what was the first step? Step number 1 is plot xk and hk. So we will plot xk and hk, right? So here we have plotted this first signal, that is xk has been plotted, right? So simply replace n with k. We will have 1 by 2, 1 by 2, 1 by 2, 3 samples. For n is k is equal to 0, 1, and 2. And we have h of k, right? Again, we have plotted h of k. 3 samples, 3, 2, and 1. That is 3, 2, and 1. Right? So step number 1 is over. Second step say that find h minus k. Right? What is h minus k? That is, we have to flip this signal hk along the vertical axis, or fold this signal along the vertical axis. So step number 2 says as find h minus k. So we have folded it along the vertical axis, and this is also known as time inversion. So we all know, we are all familiar with this particular operation. It is we have already done these numerical problem in the theory as well in tutorial classes. So hk can be obtained as from h minus k. Hk can be obtained by flipping the data sequence along the vertical axis, or by folding the data sequence along the vertical axis. So we will have now 3, 2, and 1, right, for the negative values of k. right? So step number 2 is over. And step number 3, time shift h minus k by n naught unit, right? Third step say time shift h minus k by n naught unit to obtain h n naught minus k. And the step number 4 was find the product of xk and with hn naught minus k. So we are going to do these two steps at the same time. That is step number 3 and step number 4. So we have plotted xk. ये पिछली स्लाइड से ही हमने लिया है. xk प्लॉट किया हुआ है. We have obtained h minus k from hk, right? So when the value of n naught is equal to 0, then it means we have h n naught minus k will be same as that of h minus k. जब n naught का वैल्यू 0 है तो अगर आप उसको शिफ्ट भी कर रहे हो लेफ्ट साइड या राइट साइड जैसे भी, अगर n naught 0 है तो इट मींस h n naught minus k will be equal to h minus k. We have to find the product of xk with h n naught minus k. So xk multiply by h minus k. So here we have multiplied these two signals, that is xk multiplied by h minus k, right? So as discussed in the starting classes कि जो multiplication होती है इसमें जो हम जिसको हम ऑपरेशन ओवर द डिपेंडेंट वेरिएबल भी बोलते हैं, तो इसमें मल्टीप्लिकेशन सैंपल वाइज होती है. दैट इज for x0, this x0 will be multiplied by h0, right? So 1 by 2 multiplied by 3, it is equal to 3 by 2. Then this signal at n is equal to 1, that is x1 will be multiplied by h1. h1 have a 0 magnitude, so this 1 by 2 multiplied by 0, that is 0. Then again this h2 which having magnitude is equal to 1 by 2 multiplied by 0, the magnitude will be equal to 0. All the samples on this side after k is equal to 2 are 0. Here already all the samples are equal to 0 for k greater than 0. So there will be no value in the product sequence for k greater than 0, right? Similarly, for the h minus k on the left hand side, we have h minus 1 equal to 2, but all the samples on the left hand side of xk is equal to 0. So again there will be no non-zero overlapping product, right? Non-zero overlapping product हम calculate कर रहे हैं when you multiply xk with h minus k, the non-zero overlapping product, right? इसमें non-zero product होनी चाहिए. तो non-zero product सिर्फ एक ही sample के लिए आ रही है, that is for k is equal to 0, which is equal to 3 by 2, right? So step number 5, right? This is a step number 5. This is step number 5. Step number 5 says that add all the samples in the product sequence. So 3 by 2 plus 0 plus 0 plus 0 plus 0 and so on. So y0 will be equal to 3 by 2. So hence we have obtained the output sequence, that is output signal y of n at n is equal to 0, right, in this particular step. So this step is over. Next is, let us assume that n naught is positive. When n naught is positive and say it is equal to 1, right, that is for n naught equal to 1, which is greater than 0, the signal h minus k will be shifted towards the right hand side. So this is h minus k, it will be shifted by 1 unit towards the right hand side. So this signal has been shifted. जो पहले 0 पे था वो 1 पे आ गया, जो पहले 2 पे था वो जो -1 पे था वो 0 पे सैंपल चला गया, जो -2 पे था वो -1 पे आ गया. Hence we have -1, 0 and 1 values of the samples, and their respective magnitudes are now 1, 2 and 3. This is h1 minus k. Step number 4 says that find the product of xk with hn naught minus k. So again do the product of xk with this h1 minus k, right? So product of xk with h1 minus k will be equal to, again do the sample wise product, right? That is for k is equal to 0, x0 will be multiplied by h1, right, which is currently for this sequence, this is the value, that is this zeroth the location of this zeroth sample will be multiplied by the zeroth location sample of h1 minus k. So 2 multiplied by 1 by 2, that is 1. Then 1 by 2 multiplied by 3, that is 3 by 2. This 1 by 2 multiplied by next sample which having the which has a 0 magnitude. So 1 by 2 multiplied by 0, 0. Here we have 0 magnitude, so 0 multiplied by -1. The 0 multiplied by 1 will be equal to 0 for k is equal to -1. right? So this is the all the samples that we have obtained for the product sequence, that is x1 multiply x1 multi x of k multiplied by h1 minus k. Step number 5. So this is the step number 5. Step number 5 says that add all the samples in the given product sequence. So 3 by 2 plus 1 by 1. So 3 by 2 plus 1. So y1 will be equal to 5 by 2. Right. So this is about the slide number 3. If you have any doubt in the slide number 3, then you can ask.
No, sir.
Yes, any question? Yes, any question in the slide number 3?
No, sir.
रोहन, आप ट्यूटोरियल क्यों नहीं अटेंड करते? रोल नंबर 92.
सर पहला वाला किया था लेकिन दूसरा
हाँ, एक
वाला
किया
नहीं किया
था.
था।
हाँ,
सर
तो
दूसरे
ट्यूटोरियल
वाले
अटेंड करो.
यस सर।
सर आज होगी हमारी ट्यूटोरियल की क्लास?
वो मैं बाद में बताऊंगा, क्लास के एंड पे बात करते हैं. इसके बाद कुमार मिश्रा. प्रभात कुमार मिश्रा, कोई डाउट है? मे भी चलो ठीक है, मे भी ट्यूटोरियल क्लासेस जब मैं न्यूमेरिकल करें तो उस टाइम पे थोड़ा डाउट वगैरह आए. अभी आप नहीं पूछ पा रहे तो एक बार इसका जो अपलोड कर दूंगा मैं ये शीट, तो उसके बाद आप इसको देखना अच्छे से. अगर कोई डाउट आता है तो आप पूछना. तो वी विल मूव टू द नेक्स्ट स्लाइड. Right, so we have obtained y0 and y1. Next, we have shifted the h minus k by 2 unit, right? Because n naught, h n naught minus k, n naught can be any value. जो हमने step number I think 3 था, इसमें बोला था that is time shift h minus k by n naught unit. Now n naught can be anything, right? That is n naught can be greater than 0, it can go up to plus infinity. N naught lesser than 0 can go up to minus infinity. So n naught can be any value. So that's why we are keep on taking the values of the n naught. So now we are taking n naught equal to 2. So as it is greater than 0, it will be shifted towards the right hand side. So h minus k will be shifted by 2 unit towards the right hand side. So let us see what was hk, h minus 1k. This was h of minus k, that is minus 2, minus 1 and 0, right, on the x-axis. So h2 minus k will be 0, 1, 2 on the x-axis, right? So all the samples, that is 3 samples, have been shifted towards the right hand side by 2 units. Next, step number 4, it says that find the product of xk with h2 minus k. So we have found the product of x of k with h2 minus k, right? That is 1 by 2 multiplied by 0. यहाँ गलती होगी क्या? ये कैसे हो सकता है? नहीं दिया हुआ है, ठीक है. हाँ. So 1 by 2 multiplied by 1, that is 1 by 2. 1 by 2 multiplied by 2, that is equal to 1. 1 by 2 multiplied by 3, that is 3 by 2. Right, so we have obtained the product of xk with h2 minus k. This is the step number 5. Step number 5 says that add all the samples, right? Add all the samples in the given product sequence to find the value of y of n at n is equal to n naught, right? So n equal to n naught, that is n naught is currently equal to 2. So y2 will be equal to sum of all the samples in the product sequence, that is 3 by 2 plus 1 plus 1 by 2. So 3 by 2 plus 1 plus 1 by 2, it is equal to 3, right? So we have found y of n at n equal to 2. Now next is when n naught is equal to 3, it means time shift the h minus k by 3 units. So h minus k has been shifted towards right hand side by 3 unit, right? With respect to h2 minus k, h3 minus k will be shifted towards right hand side by 1 unit, right? क्योंकि अगर इससे कंपेयर करेंगे तो इससे 1 यूनिट ही राइट साइड पे शिफ्ट होगा. बट इफ यू कंपेयर इट विद h minus k, then h minus k will be shifted towards the right hand side by 3 unit. 3 यूनिट से वो राइट हैंड साइड पे शिफ्ट हो जाएगी, right? So this is h3 minus k, that is for 0, 1, 2 and 3. That is for k is equal to 0, 1, 2, 3. We have these 4 samples now. Next step is say that find the product of xk with h3 minus k. So this is the product of xk with hn naught minus k when n naught is equal to 3. So again do the sample wise product, right? 0 multiplied by 1 by 2, that is 0. 1 multiplied by 1 by 2, that is 1 by 2, right? Next is 1 by 2 multiplied by 2 equal to 1. Then this 3, that is k is equal to 3 multiplied by 0 equal to 0. So rest of the samples will be equal to 0. So this is the product sequence, that is the step number 4. And this is the step number 5 for the n not equal to 3, right? So y3 will be equal to product sum of all the elements in the given product sequence, that is 1 by 2 plus 1, that is 3 by 2, right? Similarly find h n naught minus k for n is equal to 4. So this is h4 minus k, that is h minus k is now shifted by 4 units towards the right hand side. In comparison with h3 minus k, it will be a 1 unit shift. So all the samples in this h4 minus k compared to h3 minus k will be shifted by 1 unit. So we have shifted this 1, 2, 3 by 1 more unit towards the right hand side if you are comparing it with h3 minus k. And if you are comparing h4 minus k with h minus k, this signal, right, we have shifted all the samples by 4 unit for obtain h4 minus k from h minus k, right? So this is h4 minus k, right? Next step says that find the product of xk with h4 minus k. So we have found the product of xk with h4 minus k, that is for k is equal to 0. This is the 0th sample, that is which having a magnitude equal to 1 by 2. Here it is, its magnitude is equal to 0. So 1 by 2 multiplied by 0, that is 0. Then 1 by 2 multiplied by 0, that is 0, right? Then 1 by 2 at k is equal to 2 multiplied by 1, right? So 1 multiplied by 1 by 2 equal to 1 by 2. Then rest of the samples are here equal to 0. और यहाँ पे जो samples हैं उनका magnitude है, but this 2 multiplied by 0, that is 0. This 3 multiplied by 0, that is equal to 0. So that's why we have only one sample at k is equal to 2 for the product sequence. So step number 5 says that add all the samples in the given product sequence. So we have added 0 plus 1 by 2 plus 0, that is 1 by 2. So y4 will be equal to 1 by 2. Now what is y5 and y6? So if you shift this signal by 1 more unit towards the right hand side, you will get h5 minus k, and it will start from k is equal to 3, whereas xk is limited only for k is equal to 2. It means अगर आप इसको और वैल्यू से शिफ्ट करते हो, that is if you obtain h5 minus k, h6 minus k, then there will be no non-zero overlapping region. कोई भी नॉन जीरो ओवरलैपिंग प्रोडक्ट रीजन नहीं रहेगा, सभी जीरो ओवरलैपिंग प्रोडक्ट रीजन रहेंगे, क्योंकि ये 2 पे खत्म हो जाता है. और इसके बाद हम इसको अगर 1 यूनिट और डिले करते हैं टू फाइंड h5 माइनस के, राइट, तो वो 3 से स्टार्ट होगा, जबकि जो इनपुट सिग्नल है वो 2 पे ही टर्मिनेट हो रहा है. तो 2 तक ही उसका मैग्नीट्यूड फाइनाइट जीरो नॉन जीरो मैग्नीट्यूड है. तो उसके बाद जितनी भी प्रोडक्ट होगी एक्स के की एच एन नॉट माइनस के व्हेन एन नॉट इज ग्रेटर देन 4, there will be no non-zero overlapping product, and there will be no non-zero product sample. So that's why we have written here that is y5 will be equal to 0, y6 will also equal to 0, and so on. So hence we do not need to solve it further, right? इसके आगे n नॉट का वैल्यू लेने का जरूरत नहीं, क्योंकि xk और h n नॉट माइनस k for n नॉट greater than 4 will be a zero output sequence, right? So there is no need to find further samples. Now we will go towards the left hand side, that is when n naught is equal to n naught is lesser than 0. So it will be shifted, that is h minus k will be shifted towards the left hand side by 1 unit. So what was h minus k? This was h minus k, that is 0, -1, -2. So it will be shifted towards the left hand side by 1 unit. So let us shift it by 1 unit. So k is equal to -1 पे 3, k is equal to -2 पे 2, k is equal to -3 पे 1 magnitude, the signal has been shifted towards the left hand side by 1 unit. Step number 4 says that find the product of xk with h minus 1 minus k or h n naught minus k when n naught is lesser than 0. So all the samples will be equal to 0 because when you multiply this h minus 1 minus k with this xk, right, which is starting from 0 and ending at 2, whereas h minus 1k is completely a left-sided sequence. It starts from k is equal to -1 and ending at -3. So there will be no non-zero overlapping product region between xk and h minus 1 minus k, right? And that's why the product of xk multiplied by h n naught minus k for n naught lesser than 0 for all the values of n naught lesser than 0 will be a 0 sequence, right? So y minus 1 will be equal to 0, y minus 2 will also be equal to 0, y minus 3 will also be equal to 0, right? This is the output sequence that we have obtained now. That is for y of n is equal to 3 by 2 for n is equal to 0. At n is equal to 1, yn has a magnitude equal to 5 by 2. At n is equal to 2, it has a magnitude is equal to 3. At n is equal to 3, it has a magnitude equal to 3 by 2. At n is equal to 4, its magnitude is equal to 1 by 2. And for n not greater than 4 or n greater than 4, the magnitude of the output sequence are 0. And similarly, on the left hand side, we do not have any output sequence. जैसे हमने पिछले स्टेप में फाइंड आउट किया था, that is negative values of y of n all are equal to 0, right? और जो पॉजिटिव वैल्यूज हैं y of n की वो 4 तक की गई हैं. सो हमारे पास ये आपके पास आउटपुट सीक्वेंस आ जाएगा y of n, right? So if you have any question, then you can ask. Yes, any question?
No, sir.
Any doubt? Abhaydeep Singh, Ramneek Kaur, Dhwani.
No, sir. Clear, sir.
No, sir. Got it.
Yes, got it, sir.
Paras Goel.
Yes, sir.
कोई डाउट है?
No, sir.
तन्वी 120. स्वयं 118.
Yes, sir.
कोई क्वेश्चन हो आपका सोल्यूशन के रिगार्डिंग कोई?
No, sir. Clear.
शुभम गर्ग 112. संजीव 104. So I will upload this lecture on the Google Classroom और आप एक बार इसको देख लेना और उसके साथ जो है ओके. सो अभी जो हमने प्रोसीजर किया है कन्वोल्यूशन सम का जो एग्जांपल डिस्कस किया है, इसमें हमारे पास फाइनाइट डाटा सीक्वेंस थी, दैट इज x of n इज अ फाइनाइट एंड h of n इज अ फाइनाइट डाटा सीक्वेंस. नाउ व्हाट वुड हैपन इफ वी हैव अ इनफाइनाइट डाटा सीक्वेंस, दैट इज इसको हम इनफाइनाइट इंपल्स रिस्पांस भी बोलते हैं, दैट इज IIR, राइट? फाइनाइट इंपल्स रिस्पांस हमने पहले कर लिया. व्हाट इज फाइनाइट इंपल्स रिस्पांस? दैट इज this is a finite impulse response. If the impulse response consists of only finite number of samples, then the impulse response is known as finite impulse response, right? That is FIR. And if you have infinite impulse response, that is h of n consisting of infinite number of samples, then we call that sequence as infinite impulse response, that is IIR, right? So let us discuss this numerical problem. That is x of n is given to you, that is R of n, and h of n is given to you which is equal to U of n, right? And you have to find y of n, right? So we have first step, that is plot xk. We have plotted xk. You know that it is a ramp sequence, unit ramp sequence, right? So we have plotted it. That is R of n is known as unit ramp sequence. That is its expression will be x of k will be equal to r raised to power k, that is जो आपका सिग्नल है वहीं आपकी वैल्यू इसमें रहेगी, दैट इज व्हेन xa इज इक्वल टू 0 ये आपके पास 1 आ जाएगा, ये व्हेन k इज इक्वल टू 1 है तो आपके पास 1 मैग्नीट्यूड आ जाएगा, जब k इज इक्वल टू 2 है ये 2 आ जाएगा, राइट, k इज इक्वल टू 3 ये 3 आ जाएगा, दैट इज x ऑफ k विल बी सेम एज k। यहाँ r ऑफ k लिख दिया है, ये गलत है, ठीक है, गलत लिखा गया है, xk विल बी इक्वल टू दैट इज xk इज इक्वल टू r ऑफ k इक्वल टू k, राइट, जो k का वैल्यू है वही इनपुट सिग्नल का वैल्यू रहेगा। This is h of k, that is the impulse response. This is a unit impulse response of the given sequence, and it is equal to step sequence, that is u of n. So this is the unit step function which is currently acting as a impulse response of the system, right? We know that u of n exists for n greater than or equal to 0, that is it is a right-sided signal, right, and it goes up to infinity. So that's why it has shown with the help of these dotted lines, that is it is going up to infinity. This signal is also going up to infinity, right? So as it is going up to infinity, that is the impulse response is going up to infinity, that's why it is known as IIR, that is infinite impulse response. So what was the formula to find the convolution sum? That is yn is equal to xn in convolution with hn. Expansion is k from -1 to plus infinity, x of k multiplied by hn minus k, right? So let us substitute the individual values, that is k from -1 to plus infinity, r of k, that is x of k which is given to us, multiplied by un minus k, because hn k is h of n is u of n, and what will be hn minus k? That is un minus k, that is the time shifted version of impulse response which is currently equal to u of n. Now if you look at this expression, right, it we can because this signal that is r of k, that is x of k, it exists only for अभी इसको छोड़ते हैं, यही स्टेप तक रहते हैं, राइट? सो दिस अप टू दिस स्टेप इट इज क्वाइट क्लियर टू अस, वी हैव ओनली सब्स्टिट्यूटेड द वैल्यूज। नाउ वी हैव टू शिफ्ट दिस सिग्नल, दैट इज u ऑफ माइनस k जो है इसको हमने शिफ्ट करना है बाय n नॉट यूनिट इधर टुवर्ड्स द लेफ्ट हैंड साइड और टुवर्ड्स द राइट हैंड साइड। सो लेट अस अज्यूम दैट द केस नंबर 1 व्हेन n नॉट इज इक्वल टू n naught is greater than 0, right? That is n naught is greater than 0. We know that when n naught is greater than 0, the impulse response will be shifted towards the right hand side. So step number 2 says that hk is given to you, find h minus k. So what would be h minus k? This is h minus k, right? H minus k, that is from hk we have obtained h minus k. We have folded the signal towards the along the vertical axis, and we have obtained h minus k from this u of k. तो ये हमारे पास सिग्नल आ गया। अब n नॉट हम ग्रेटर देन 0 ले रहे हैं, इट मींस दिस सिग्नल विल बी शिफ्टेड टुवर्ड्स द h minus k will be shifted towards the right hand side, right? That is for n not n greater than 0, it will be a right shifted signal. So कहाँ तक right shift होगा? तो हमने एक जनरल एक्सप्रेशन लिख लिया, that is k from 0 to n. n का वैल्यू कुछ भी हो सकता है, 1 2 3 4 जिससे भी आप शिफ्ट कर रहे हो, तो हमने एक जनरल एक्सप्रेशन लिख दिया। तो इसमें क्या रहेगा? hn minus k will be shifted towards the right hand side by n naught unit. तो हमने इसको n naught unit से right hand side शिफ्ट कर दिया, where n can be equal to 1 2 3 4, उसके अकॉर्डिंग ग्राफ मॉडिफाई हो जाएगा। So we are trying to find the general expression, right? Now step number 3 says that step number 4 says that find the product of xk. Step number 3 and 4, find the product of xk with this xk with hn minus k, right? So we have find the product of this signal with this signal. So it will start from k is equal to 0, right? K is equal to 0 से start होगा and it will go up to n, क्योंकि इसके बाद तो हमने सिग्नल को शिफ्ट नहीं किया, तो सभी सैंपल्स इसमें 0 हैं। इस सिग्नल में तो इनफाइनाइट तक सैंपल जा रहे हैं, बट हमें सिर्फ वी आर इंटरेस्टेड ओनली अप टू that particular instant where we can find the non-zero overlapping region or non-zero product region, right? So non-zero product region between this signal which is starting from 0 and ending at plus infinity, and between this signal which is starting from some minus infinity point and ending at equal to n. So non-zero overlapping product region will be only from starting from 0 to n. So that's why we have written k is equal to 0 to n. Now what is hn minus k? Its magnitude are equal to 0, because we know that the step sequence have all the magnitudes equal to 1 only, right? इसके सभी magnitude 1 होते हैं unit step sequence signal के. तो हमने 1 multiply by इसका क्या magnitude रहता है? This is equal to k. So k multiply by 1 will be equal to k. So we have here k. Now you can find the sum of this sequence. k का वैल्यू जैसे 0 होगा तो यहाँ पे जो है वो आपके पास 0 आ जाएगा, फिर 1 आएगा तो 0 प्लस 1 प्लस 2 प्लस 3 प्लस 4, राइट? इस तरह से आपके पास आ जाएंगे. इस जो का रिजल्ट बनेगा दैट विल बी इक्वल टू n into n plus 1 divided by 2. आपके सीक्वेंसेस पढ़ी होंगी मैथमेटिक्स में, तो उसमें एक सीक्वेंस रहती है स्टैंडर्ड नोटेशन है, आप करके भी
Excuse me, sir, your voice is lagging.
Okay. So I had just said that we have to find the product of xk with hn minus k, and as xk is starting from 0 and ending at infinity, whereas the signal with which this signal has to be multiplied is only existing up to n naught instant, right? So when you try to find the non-zero overlapping product, then the summation will start from 0 and end at n only, right? Because this signal is existing only up to n, and when you solve this summation, it will be equal to n into n plus 1 divided by 2, right? Similarly, second, n is lesser than 0, this h minus k signal will be shifted towards the left hand side. But now when you try to find the product of hn minus k with the xk, as xk is a right sided signal, and this signal h minus k is a left-handed signal, so there will be no non-zero overlapping product region here, and the y of n will be equal to 0, right? So this will be the solution, that is y of n equal to n into n plus 1 divided by 2 for n greater than or equal to 0, and it is equal to 0 for n lesser than 0. So in this way we can find the solution for infinite impulse response. So we will discuss the doubts in the tutorial class when we try to solve more numerical problems. तो उसमें अगर आपके doubts होंगे तो आप पूछ सकते हो, आप अपने प्लेस पे इसको ट्राई करके देखो अलग अलग numerical problems, ताकि आपके जो doubts होंगे वो tutorial class में clear हो सकें. ये दोनों lecture notes जो है वो मैं Google Classroom पे upload कर दूंगा, आप इनको भी रेफर कर लेना, ठीक है? तो अगर किसी का क्वेश्चन है तो आप पूछ सकते हो. आज ट्यूटोरियल है ग्रुप नंबर 5 का, तो 3 से 4 के बीच में है. अगर 3 से 4 के बीच में आज मैं फ्री नहीं हूँ, आप कोई और टाइम बता दो आज का, अगर आप कर सकते हो, जैसे 2 से 2:30 के बीच में, या 2 से 2:45 के बीच में, या फिर कल का कोई टाइम दे दो मेरे को सैटरडे का. इस ग्रुप नंबर 5
सर किसी दूसरे ग्रुप के साथ एडजस्ट कर लेना हमें भी. जब मान लो ग्रुप 4 का हो तो हम साथ में काम कर लेंगे.
तो फिर नेक्स्ट वीक पे रहेगा, फिर नेक्स्ट वीक में
Yes.
2 ग्रुप्स का एक साथ ट्यूटोरियल रहता है, उसमें आप ज्वाइन कर लेना फिर.
यस सर.
यस सर.
सो ये जो नोट्स हैं वो अपलोड कर दूंगा, आप सब लोग इसको रेफर कर लेना. फिर नेक्स्ट क्लास जो ट्यूटोरियल रहेगी उसमें हम ये न्यूमेरिकल प्रॉब्लम जो है वो डिस्कस कर लेंगे.
ओके सर.
ओके, थैंक यू वेरी मच.